Hello everyone and welcome to another video. Now in this video I am going to cover pretty much Git at a high level, so it can get you up and running if you need to use it on a project or something at work, or if you're just trying to figure out a way to use it in your own personal projects and stuff like that. So without further ado, we'll get right into it. Right, so what we're looking at the moment is my GitHub. This is just a repository that I have on GitHub, which pretty much has a step-by-step guide on what I'm about to go through. So a link's going to be in the description for this. But what I'm going to do is pretty much walk through this and talk about each step, and then pretty much just cover everything as a whole at the end of this. So what Git is just a way, it's just a source control. It's a way that we can easily manage our code, and it also makes collaboration and stuff like that a lot easier. So there's many sites that you can use Git with. So there's GitHub, there's GitLab, there's Bitbucket. There's like the Azure, DevOps has one, AWS has one, GCP has one. So there's all these places that we can store Git repositories and stuff on. It's just a matter of, they might use different terminology and stuff, but pretty much what I'm going to teach you today is pretty much going to be relevant across them all. They just might use different names for certain things, and I'll cover that as we kind of approach it as well. So what we're looking at here is just a basic repository. Like I mentioned, it's actually just hosting a basic website. So at the moment you can see I've got something called index.html. This is essentially just a file that I have in here that has just hello world and another edit here. And then if we go back, there's a CSS file with nothing in it. So this is just pure basic stuff in it. And then if you genuinely have a readme.md file, MD stands for markdown, in your repository, then the readme is normally presented in a way like this at the start. So a readme is generally where you would put information about your repository, so if someone comes into it, they can just immediately see what you are talking about or what this repository is for. So let's talk about forking a repo. So at the very start, so forking a repo, as you can see here that I've got here, this can be done by, if you go onto any repository, you can click the fork button. So what this means is that you will grab their code and everything in their repository, and you will essentially copy it and put it under your name. So see here, let me zoom in a bit so you can see a bit better. You can see here I've got this thing called tw-git. Now if you were to copy this, rather than it being TechDocs, which is my name, it would be your GitHub name, and then it would be under your name, but the repository would be from copied from mine. So that's just a way of, say if there was a project that someone was working on, but you didn't have permission to work on that repository under their name, you would fork it, and then you could make changes and stuff like that under your own name and use it for your own way. And that's pretty much open source in a nutshell. You can, if someone's working on a project and you like the look of that project but you want to make some changes for yourself, you can make a fork of it, make some changes, and then that would be a different version of that program or something like that. Now let's say that you want to clone a repo. So cloning a repo, there's a couple of examples that I can use for this one. So either you've just forked a repository, now it's under your name, and then you can clone the repo. So what this is doing is it's pulling it down from GitHub onto your local computer. So you've got a exact copy of that repository, but now it's locally on your computer. Or what it can mean, rather than cloning a fork, you can just clone your repository here or someone else's. It's just pretty much copying someone's repository from GitHub or whatever service you're using, and it's creating a local version on your computer of that repository. So what I'm going to do is I'm actually going to run this command on this repository here so I can show you. So what you can see here, I actually just have a terminal window open, and I'm going to run that command that's just behind this window, and that will clone the repository locally on my computer. So this is just a normal terminal window that I have open at the moment. So to clone a repository, all you have to do is click on the code button up here. Again, this is normally pretty common across all the Git services, like I was saying, GitLab and Bitbucket and stuff. They would have something called code or clone or something, and you just click here and then they would have the link that you would copy. So you'll see that there's actually three types here, where there's the HTTPS and you could copy that, or the SSH version. So the SSH would allow you to copy it if you have your SSH public key attached to your GitHub profile. You can just do that by going into, clicking it on the top here, and then going into settings. And then when you're in settings, what you can do is go down to SSH and GPG keys, and then you can upload it there. I already have an SSH key uploaded, so that will allow me to download it. And then what you've got here is also HTTPS. So again, there's multiple reasons why you would use HTTPS over SSH. The reasons being, maybe you're on a client network where they don't allow SSH connections and they only allow HTTPS connections, or vice versa, or something like that. And if this was a private repository, so you can have, so this is public so anyone can see it, if it were to be private and then I was downloading via HTTPS, it would ask me for my credentials. And since it's public, I don't have to enter in those credentials. But again, if it was private, if I were to do this HTTPS download or this clone, it would then ask me for some credentials. But you don't even need to be logged in to clone a public repository via HTTPS. But again, if it's private, you do need to be logged in, and then it would ask you for credentials. So what I'm going to do, since this is a public repository and I have my public key in my GitHub profile, I can actually just copy this and then do that command that you can see here, which is to git clone. So git clone, paste that in, and hit enter. Now that's grabbing that repository in GitHub and it's making a copy locally. So now if I just list what's in my repository, I can see that I have, list in the folder that I'm in, you can see the repository. Now we can change into repository, just clean up the screen a bit, hit ls. Now you can see I have the exact same files here. So what this means is now I can work on these files locally, or say if it was a bit of software I wanted, now I can use that software on my local machine. Now let's say I want to make some changes to this, right? So what I can do is I can edit these files in any text editor, or within, like, since I'm in the terminal, I can open up a terminal text editor like Nano or Vim, but for the sake of this video I am going to use Visual Studio Code to make some changes to this. Then I'll show you how I can commit those changes and then push those changes back to this repository and update my files here so they're in sync with my local repository. So for me to open up Visual Studio Code, all I have to do is write code and then dot, and then we'll open up Visual Studio Code in this local directory that I'm in. Now the great thing about having Visual Studio Code, you can get a lot of extensions as well that will let you see some certain Git commits and stuff like that, and just to be able to see a lot of what's happening in your repository. So at the bottom down here, I don't know if you can see, it says that I am on the main branch. Now don't worry, I will cover branches in a second. I just know that we are working on the main branch, and you can see all of that in the Visual Studio Code, which is quite nice. So let's say I want to make some changes. I want to change Hello World 2021. I'll actually keep that, and now let's put in a paragraph, and we'll just say hello, this is a test, and we'll save that. That's the change we were going to make, and we're happy, and now we want to push this back into GitHub, so it's up to the GitHub repository is up to date with what we have locally. So now let's go back to the GitHub repository that I have and see the commands that we'll be running. So as you can see here that once we've cloned it, if any changes that we make, we can run this command here, git add. So you'll see that I have git add and then I have a full stop at the end. So what git add and then the dot means is that it will get all the changes that I have made, and it will add them all ready for a commit. So let's say, for example, I made 3 changes to 3 different files, right? And then if I did git add dot, which is this one here, it will get all those 3 files ready for a commit. And then when I did git commit, this one here, with a message saying, let's say, fix bugs, that message fix bugs would be attached to all 3 of those files. Where if I wanted to do it individually, say git add index.html, then I'll do a git commit saying fixed bug in HTML or index.html. Then I'll do git add the other file, so the message is separate on each one. But for the sake of this, I'm going to keep it real simple just not to confuse anyone, and I will do git add dot, which will add all the changes, get the files ready for a commit to all the files that I've made changes to. So if I clear this and tidy it up and do git add dot, so now what that means is you can see it says +1. You probably won't see all this stuff here. This is actually an extension I have. If you're interested in getting it, I can do a video showing you how to set it up. But what we've done is we've got the file added ready for a commit. So now what we can do is the next command, which is git commit -m, which means we are going to put a message on with our change so it can be tracked, as you can see here. So let's say git commit -m, and let's say added text to index.html. Right, so that's our message, and now let's commit that, and now you can see that there's one file has been changed, which was our index.html, and there's been one insertion, which was that paragraph line that we put in. Now our change has been added and it's ready to be pushed. So how do we do it? So all we need to do is run git push. So if we do git push and hit enter, you can now see that our change has been pushed to our repository. So if I come back up here and I refresh, you can see here that index.html was updated 34 seconds ago, and the latest change, this is our commit message is added text to index.html. So if I come into this file here, you can see that now this has been updated from my local repository. Changes have been pushed to the GitHub repository. Now, so we're going to come to the part about branches now. So you might have heard me talking about when I was in the Visual Studio here, there's a thing called branches. So at the moment, we are working on the main branch. So think of it as literally a branch, right? There's a repository here, and then there's just a single branch. Now, if you were just working on this yourself, sure, working on one repository, one branch might make sense, or it's just easier. But when you're on a project and you're collaborating with a lot of people, what can happen is that you can get, let's just put an example here. Imagine if one person is working on index.html here, and I am also working on index.html, and then we upload our changes. There's going to be some conflicts, right? Because I might have changed one part of paragraph and he's removed the paragraph because he doesn't want to use it and he's used something else. There's a lot of conflicting with our code changes, right? So what do you do? So this is when branches come in. So let's come down here and we'll talk about it. So what I've got here is, I'll just read this out. For best practice, all development should be done on a branch other than master or the main branch. Such as default, we would create a branch called development or something. So once the changes on the development branch have been tested, and then we've gotten some people to look at those changes we've made and approved, then those changes from that development branch can be merged into our master or main branch because we know it works. So the great thing about that is that you've got actually a review on the code that's been changed. Again, I'll show this all in action as well. So how do you make a branch? So there's two ways. You can make it in GitHub, or you can just do it locally on your local repository. So let's go up and I'll show you how to do it in GitHub. So if you scroll to the top and you click here, you can actually just type in the name. So let's say this will be git dev. So since it doesn't exist, we can just click here, which says create branch git dev. So if I click here, now you can see that we are now on a different branch and it's called git dev. So any changes we make here are actually just changed to git dev and not the main branch. Now let me show you how to do it locally. So if you want to do it locally, all we have to do is run git checkout -b, and then the -b is we give the branch a name that we want to use. As you can see here, the above is actually shorthand. We could do the exact same by doing git branch and then the name of the branch, and then git checkout and then the name of the branch. So create the branch and then use that branch essentially. And this command here will do both those at once. So let's copy that come up to here, clear the screen a bit, and we'll paste that in, and let's call this one our local dev, so our local branch. Normally you would just have like dev or features or stuff like that, but I'm just keeping it quite high level. So now we've made our changes. So what do we do? So now let's go back to GitHub. Sorry, not GitHub, our Visual Studio Code. And now you can see we are on the local development branch. And we still have our main branch, but we also have our local dev. So let's make some changes to this. We'll put another paragraph line in here. And let's just say, hello, local dev branch. All right, so this is a change, but this change should only appear on the local development branch. So let's have a look. Let's commit these changes, push them up, and see where they appear. So we'll do the same, git add, and then just to show you, you can do the index.html rather than the dot. So we've got that change ready. Now we have to put a message on saying what we changed. And let's just say added a new line for local, oops, let's spell that right, local dev. And then we'll push that to GitHub. Now, as you can see here, this will push to our local dev because we are on it, but if you want to make sure that when you push it, it's going to your correct branch and not to your master branch by accident, what you can do is type in origin and then where you want it to go. So local dev. So what this is saying is push this to the branch local dev. So hit enter, and now watch this. So GitHub has now found out, hey look, local dev didn't exist in our GitHub up here, but since what we've done when we pushed it, it's created that branch for us. So now if we click here, and we'll give it a bit of a refresh actually, and click down here, we can see that new branch is now there. But now if we come down to here and click here, we've got local dev, right? And we've got our main, but we don't have the Git branch that we made, right? We can't see Git dev. Why is that? Well, the changes that we made are all still on GitHub. We need to make sure that our local branch, even though we can work remote, like without being online and whatever with it, we want to make sure we're up to date with it. So what a command you can do to make sure you're up to date is you can actually run a git pull. Now I don't actually have that command here in my documentation, but so what you can do is do a git pull. Now this will check if there was any new branches or any code changes made, and as you can see here, it has found that there is actually a git dev and it's a new branch. So if we come into Visual Studio Code, and then we can see we now have that git dev branch just by doing a git pull. So now let's go make sure those changes that we made to our local development branch are actually there. So we click on the local development branch and we can click on the index.html. And now we can see that we now have that new line that I made. Now, if we go down here and go to our main, we can see that that change has not been affected. It hasn't affected our main. So if we're just implementing and developing and we're testing things, we know we're not going to affect our main branch. So your main branch should essentially be seen as the source of truth, or your working branch. You know that if you were to create a branch off of main, that it's taken from a working or the best source of truth you can, rather than people just making all these changes and untested changes to it, and then you're making branches from it. It can get very messy. So your main should be protected, and only known working code should be pushed to your main or master branch. So that brings me to, how do you, once you've tested your code that you've made on your own branch, what's the process look like for getting that into your main or master branch? So as you can see here, what GitHub said is that, hey look, we've noticed that there's a recent push has been made on this branch. Do you want to go through a compare it to the master branch or the main branch and put in a pull request? So we'll click here and I'll talk you through what a pull request is. So as you can see here, it's got a couple of things here that I'll talk over. So as you can see here, we've got the local dev branch here, and it's got an arrow saying it will go into the main branch, but it doesn't have to go into the main branch. We could say actually local dev will be pushed into or merged into the git dev, and then maybe git dev then goes into your main or master branch. This can be as complex or as easy as you make it. That's entirely up to you. I'm just talking about all these different scenarios that you could face. So the reason, again, you would do this is because you've got all these different people working on a project, and one person's implementing, I don't know, say a chatbot, and another person's implementing a store. You want to make sure that when those changes are implemented, that they can be merged properly and that someone's checking your code. And this is why you create a pull request. So here, let's do a bit of I'll do a bit of an example. I want to merge my local dev onto the main repo, and when it gets merged into the main repo, it will update our production live website. So what I'll do here is just say added new line, please check and approve. So I've got here a little message to anyone who's going to check this pull request, and what they will get is, if you were in a team and other people collaborating, what you could do is actually click on reviewers, and you could type in the name of those people to review it, and then they would get a message saying such and such has created a pull request and added you as a reviewer, please check their code. And this is what that would look like. So let's create a pull request, because we want to merge local dev into the main master branch. Now, first thing you'll see is that the branch has no conflicts with the base branch. So that means that what's in the base branch and what I'm adding, there's no conflicting of code. So that's a good thing. And that means that, that first step is done. We're not just chucking and trying to fit things in, fit code in where it's not going to work. Takes that step. Just to double check that your code is going to merge correctly. So now let's come in and say I was someone who just got a message to check the code that's just been changed. So what you could do is you come in and you look at the commit and you'd say, okay, so and added a new line for local dev. Okay, so it's not really a descriptive name that I've put here, but let's see what's been changed. We can see by the green line here that this is the added change. So I can see here a new paragraph has been added. Hello local dev branch. So let's just say, yep, that looks good. There's no issues with the code that I can see. So what will happen here is that someone would have a little tick mark up here, which I don't, but they would select yes and say once you had two people green light it or put a green tick saying, yep, they approve this change, you would then come in and hit merge pull request. And we'll go confirm merge. And now what this means is that the branch that you have, the two branches, say dev local, is all that code that's been sitting in here. People have reviewed it, said, yep, that is good. I can't see any issues. GitHub has automatically checked to make sure that there's no conflicts with the code. Now that code has been merged into the main branch. So now let's check the main branch and see what changes have been made. So we're on the main branch, as you can see here. And now we can see that, okay, and change has been made, added a new line for local dev. Let's look at the main index.html now. And now we can see that new change has been made. So that is essentially Git from a high level. Now I'll just quickly run through it again. So forking a repo is when you take someone else's repository and their code and you put it underneath your account, so you can make your own local changes and stuff like that to it. And so it's essentially you can make your own custom changes without having to ask them to do it. Since it's open source, you can make all those changes. Now cloning a repository is that's when you grab it from GitHub and you put it down onto as a local repository on your computer. Now keep in mind, if it's a public repository, you can clone any repository locally without needing credentials. But say if it is a private repository that you are going to download or clone from, you will need to either use your credentials or an SSH key to be able to do that. Now when you make your changes, again there's a 3-step process: git, add, and then the files that you made changes to. But if all the files that you made changes to can be put under the one commit message and it makes sense, then you can do git add dot and then git commit -m with your message, and then git push to push your changes locally up into GitHub. And again, best practice, don't use the master branch for your live changes. You should be working on a separate branch and then get those changes approved, and then they are merged into the main branch. Now once those changes are approved, you can then merge them into your main branch by raising a pull request and getting everything checked and approved, and then that will allow you to create that merge. So before I end the video, I just wanted to quickly show you kind of how this works. So I know it's a little blurry, but you've got the single source of truth, which is your master branch, and then you can have all these different branches come off. So you know what I mean? So this branch is based off this one, but in the end, they are all linked to the master branch. So if you're making all these crazy changes to here, that means that and there's an error with this master branch, all of these branches will also have that same error, where if this is always up to date, and everything is checked before it's merged with the master, you know your master will always be reliable and it will always be a good place to start from. But yeah, that pretty much sums up the video for this. I hope it makes sense. If you've got any questions, please let me know in the comments below. It can be a little confusing for the first time, but if you want, feel free to fork this repository, make some changes, and then you can merge it with my files here, and that will help you get an idea on how to do pull requests and stuff like that. So yeah, feel free to fork this, clone this repository, do whatever you want. It might be a good way just to see all the commands and stuff here. But anyway, thank you for watching, and I'll see you in the next video. Bye.